translator. The options. So, having asked you to mute it, can you just one of you let me know when you can actually see the screen saying you using integration?
Yeah, see it.
Yeah, I can see the screen.
Lovely. Okay, so just to remind you of what we've done so far, and it will also lead us into going the other way. When we differentiate, we can start off with displacement, which is obviously distance. And when we differentiate displacement, we get velocity. And similarly, when we differentiate velocity, we get acceleration. So we are able to go from displacement to velocity to acceleration by differentiating, and that's what you've been doing up to now. You can, of course, go the other way. So if you are given the acceleration equation, you can integrate it to get velocity. And similarly, if you're given the velocity equation, you can integrate it to get displacement. So 11D is all about integrating to move to the equations that you want and using those. So it's pretty straightforward. I think because we don't have tomorrow's lesson, obviously you appreciate it's the bank holiday tomorrow, you've got a bit of time for these. I think if we can try and get these done for Wednesday's lesson, that would be good, please. So let's just have a quick look at the two examples before the exercise. So in example 6, the particle is moving on the axis at time t equals 0. The particle is at the point where x equals 5. Okay, so it's starting off along at 5. The velocity of the particle is given in this equation, and they're asking us to find an expression for the displacement for part A. So we need to move from velocity to displacement, so we're going to integrate the velocity equation. So just to remind you, to integrate, you add 1 to the power and then divide by the new power. So the 6t, we add 1 to the power, that's t squared, divide by that 2, 6 divided by 2 is 3. So when we integrate that first term, we get 3t squared. And then when we integrate minus t squared, add 1 to the power, divide by the new power, we get t cubed over 3, or a third t cubed. And don't forget the constants. All right, when you integrate, you've got this constant. Now, they tell us a fact. They tell us when t equals 0, the displacement equals 5. So we can substitute that into this. So 0 minus 0 plus c equals 5. So our constant must be 5. So our displacement equation is that, but now we know c is 5. So that is our final answer for part A. And then part B, simple enough. The distance from its starting point when t is 6, you just substitute 6 into that equation that you've just worked out. So pretty straightforward part B. Okay, so example 7, similar in as much that we've been given the velocity equation and we're going to integrate it. Whoever's just joined us, if you could just switch your mic off, that would be great. It's giving a bit of buzzing sound. Thank you. So example 7, so we're given the velocity equation. We've been asked to work out the distance traveled, so we're going to want the displacement equation. So we're going to choose to integrate this. So when we integrate this, 5 becomes 5t, and minus 3t squared becomes t cubed. Adding 1 to the power 3, dividing by the 3, 3 is cancelling out. Now, it's asking for the distance travelled in the third second. So the third second is when you go from the beginning of the second, start again. The third second is 2 seconds have finished, and it's going from 2 being finished to the end of the third second. So the boundaries for our integral are from 2 to 3. That's how far we go in the third second. It's from where we were after 2 seconds to where we are after 3 seconds. So substitute 2 and 3 into the equation, and we get minus 14. Now you will see, if you sketch this graph, that we are expecting the displacement to be a minus number because it's below the curve. It's absolutely fine. Okay, so the displacement is minus 14, but because the question actually asks just for the distance travelled, that's always the positive numerical component. So that's why the final answer was 14. Okay, displacement is a vector, distance is a scalar quantity. And then the only other thing I wanted to mention, and I can't remember if this crops up in the exercise or not, just be careful when you're doing a definite integral like this, that it's the area that you want doesn't cross the x-axis. If it did, you would need to go and work out the two separate bits and add them together, because otherwise they're going to be netting off, aren't they? You can have a bit of positive area, a bit of negative area, and if you just try to integrate across the whole stretch, they cancel each other out a bit. So, but we're fine here. We're going from 2 to 3. It's all below the curve. So that's just something to watch out for. And as I said, I can't remember whether that crops up in the exercise or not, but it might do. Okay, I think that was really all I wanted to do. I haven't, well, these 11D's been done for a long time, so it's not like I've amended this recently. So any copy, any PDF copy you've got of exercise 11D will give you all my worked examples, which may help, they may not. Okay, guys, that's all I wanted to do. I'll leave you to get on with 11D. So if you could try and get 11D done by Wednesday, that would be super. As always, if there are any questions you're getting stuck on, just send a little note through to me, just post it through to me on Teams, and I will go and upload a video to explain whichever question you are stuck on. So have a good bank holiday weekend, guys, and I'll speak to you soon.
Thank you. Bye.
Cheers, guys. Okay, bye, guys. Have a good bank holiday weekend.